When you're grinding through algebra problems, it could feel like you're doing the same long steps over and over. But what if I told you there are secret shortcuts, hidden patterns just waiting to be found? Today, we're going to go on a pattern hunt and find them.
So if you see a problem like this, your first thought is probably, okay, I'll just write out x plus 7 times x plus 7 and FOIL it. And yeah, that works. But is it the fastest way? The answer is a definite no. And by the end of this, you're going to see a much quicker path.
Here's our game plan. We'll start with what we already know, then we'll investigate two super powerful patterns, the perfect square and the difference of squares. After that, we'll practice a bit, and then I'll show you why getting this down now is an absolute game changer for what's coming up. All right, first up, let's do a quick warm-up and talk about the multiplication we're already familiar with.
You know this guy, right? The FOIL method. It's our trusty, reliable tool for multiplying two binomials. It never lets us down. But here's the thing. Getting really good at algebra isn't just about knowing the long way. It's about spotting those chances to work smarter, not harder.
And now for the really fun part, the investigation. We're going to put on our detective hats and look for a hidden structure in a common problem. This is going to lead us right to our first special pattern, the perfect square.
Our first piece of evidence is this, x plus 5 squared. And we all know squaring something just means you multiply it by itself. So what we're really looking at is x plus 5 times x plus 5. So let's go ahead and use FOIL. First, x times x gets us x squared. Outer x times 5 is 5x. Inner 5 times x is another 5x. And last, 5 times 5 is 25. So far, so good. Nothing new here.
Now, we just need to clean it up. We combine those like terms in the middle, the 5x and the 5x, and we get 10x. So our final answer is the trinomial x squared plus 10x plus 25. But wait, don't just accept it and move on. The secret is right here, hiding in plain sight.
Okay, let's look closer. Think back to our original problem, x plus 5. Where did that 10x in our answer come from? Well, it came from adding 5x plus 5x. That's 2 times the product of our original terms, x and 5. And that last term, 25? Well, that's just 5 squared. That seems way too perfect to be a coincidence, right?
And it's not. This is it, our first pattern. It's called the square of a binomial. It means that for any two terms, let's call them a and b, when you square their sum, you always get this exact result, a squared plus 2 times a times b plus b squared. Our last problem fit perfectly. A was x, b was 5.
Okay, that's cool for addition. But what happens if there's a minus sign in there? Let's investigate 2x minus 3 squared. Again, all this means is we're multiplying 2x minus 3 times itself. Let's see if our pattern holds up.
Let's run through it. First gives us 4x squared. Outer is 2x times negative 3, so that's minus 6x. Inner is negative 3 times 2x, which is another minus 6x. And last, be careful here, negative 3 times negative 3 is a positive 9. So when we combine those middle terms, we get our final answer, 4x squared minus 12x plus 9. And there it is, another pattern. And look how similar it is. When you square a binomial with a subtraction sign, the only thing that changes is that the middle term becomes negative. The first and last terms are still squared and they're still positive. That's our second shortcut. So we've seen what happens when the signs are the same. But what if they're different? This leads us to my absolute favorite pattern, the one I call the vanishing term. You're about to see a little bit of algebra magic. So let's check this out. X plus 3 times x minus 3. Take a look at the setup. The terms themselves, the x and the 3, are identical in both. The only difference is the sign in the middle. One is a plus, one is a minus.
Let's FOIL this and see what happens. First, x times x is x squared. Outer, x times negative 3 is minus 3x. Inner, positive 3 times x is plus 3x. And last, positive 3 times negative 3 is minus 9. Now stop. Look very, very closely at those two middle terms. We have a negative 3x and a positive 3x. They're perfect opposites.
And what happens when you add opposites together? They go to 0. Poof! They cancel each other out completely. They vanish. That's the magic. And all we're left with are the first and last terms, x squared minus 9.
This right here is our third and final shortcut, the sum and difference pattern.
Anytime, and I mean anytime, you multiply two binomials that are identical except for that sign in the middle, you don't even have to think about the middle terms. The answer will always be the first term squared minus the second term squared. It is the cleanest shortcut of them all.
Okay, we've done the detective work. We've uncovered the patterns. Now it's time to actually put them to work.
All right, your turn. Take a look at this. 3x plus 4 squared. Which of our patterns does this look like? Go ahead and pause here if you need to, and try to find the product using the pattern, not the full FOIL method.
So how did it go? Let's break it down. This is the square of a sum, our first pattern. Our a is 3x and our b is 4. The pattern is a squared plus 2ab plus b squared. So we square the first term, 3x squared, which is 9x squared. Then we do 2 times a times b, so 2 times 3x times 4, which gives us 24x. Finally, we square the last term, 4 squared, and get 16. Put it all together, 9x squared plus 24x plus 16. See? No FOIL needed.
We're at our last section. You might be thinking, okay, these are some neat tricks, but trust me, this is so much more than that. Let's talk about the road ahead and why this is an absolutely crucial skill to have. Check this out. Everything we've done today has been going in one direction. We start with factors and we multiply them to get a final product. But algebra is all about being able to go both ways. Very soon, you're going to have to do the reverse. You'll start with the product, and you'll have to work backward to figure out what the original factors were.
So I'll leave you with this final puzzle. Look at this expression, x squared minus 49. Does that structure ring a bell? It's one thing squared minus another thing squared. Based on that sum and difference pattern we just uncovered, can you guess what two factors you would multiply together to get this? Think about it, because that is exactly where we're heading next.